Okay, this is going to be a bit long to read out, but bear with me. So the learning objective today is to define percentages as numbers of parts per hundred, interpret percentages as percentage change as a fraction or decimal, and interpret these multiplicatively, express one quantity as a percentage of another, compare two quantities as percentages, work with percentages greater than 100%, solve problems involving percentage change, including percentage increase, decrease, and original value problems, and simple interest, including in financial mathematics. Very long-winded or long-sounding learning objective, but percentages basically, if you haven't seen them before, you probably have actually seen them before, but there's always this sign or this sign. You might see when you're going sale shopping, sometimes you see something like 50% off, screaming, and usually it's always up to 50% off, and they've hidden that up to, but you'll see something, it's the screaming 50% off, 70% off, or whatever, maybe on a holiday sale, for example. And percentage, so the word percent, you have percent, and actually, it used to be two words. It used to be percent, and you can see where I'm going with this. So it's per, and cent is from Latin, comes to like 100. So it means per 100, right? So that's what percentage comes out to. It means per parts per 100, basically. So, if you have something like 1%, that just means it's 1 over 100 of something. So if it's 1% of, people, it's 1 over 100th. It's 100th of people. So, 1% of the population, for example. So the population of the UK is like, 60 million. What is 1% of the UK population? You say, okay, it's 1%. 1% just means 1, and then whatever the percentage is, divided by 100. 1/100th of 60 million times by 60 million, which comes out to 0.6 million. Or for example, if I was asked to ask you what, say, 15% of the population is, well, let's say 20, that's a nicer number. 20% of the UK population. Well, if 1% is 1/100th, well, 20% by that same thing is 20/100th. That's the definition of percentage. So if you want to go from a percentage to a fraction, all you do is divide by 100. So you go 20 divided by 100, and now you know how to find 20/100ths of the population, right? You just 20 over 100 times by 60 million, which comes out to 3 million. 3 million? Or, yeah, 3 million? Yeah, was it 3? So, yeah, so 12 million, oh god, sorry. 12 million, not 6 million, 3 million. Comes out to 12 million. So, you just multiply that, and there you go. So, it's easy. So we've done the first part, and also, if you want to go from percentages to fractions, that's simple enough. If whatever percentage you have, if you have X percent, you just do X over 100. So if you have, say, 50%, convert that into a fraction, just positively give that a go. Or you just go 50 over 100, which is half. Or if you were to convert, say, 74.985%, well, you just do that, divide by 100, so 74.985 over 100, and then you can simplify this as you will. And so now that you know how to convert from percentages to fractions, you know how to convert them to a decimal. You can do this, and now you can convert a fraction, you can convert it to decimal. But also, there's a neat trick, because if you're dividing by 100, if you remember our place value thing, what you're going to do is effectively just stick a 0.5 on there. So if it's 0.50, if it's 50%, it just goes to 0.50, which is a half. So if you have, say, 70, if you have a number like this, 74. You just move the decimal point 1, 2 along to get there, 0. Remember, that's how we divide by tens. So if you have something like 1%, well, you move the decimal point from or we don't see one explicitly, but we know there's one here. We go from 1 along and then 2 along, so we get 0.01. So that's how you convert from percentages to decimals. So we've thought about how to what percentages are, again, parts per 100 or 100th, and how to convert them to fractions and to decimals. Well, you're probably thinking, what's the point of having percentages at this point? Like, we've already got fractions and decimals, right? But basically, this is the same thing of saying, what's the point of having fractions if we've got decimals, or what's the point of having decimals when we have fractions? it's just sometimes a bit easier to represent things in terms of fractions or in terms of decimals. You don't always want to say something like 54 and a half, right? Like 50. You don't always want to be seeing 54 and say 5957 over 1000. You might want to see just a bit easier on the eyes if we write this, right? And by the same logic, sometimes we have percentages because it's a bit easier in life. Sometimes if you have 50% off, you can say kind of up to half off, right? Or kind of up to a half off, but kind of, what happens if you had 75% off? You'd say up to 3/4 off. I mean, that just doesn't sound as kind of nice. But so 50%, we've just kind of developed another way of, saying this kind of stuff, the parts per hundred, and we just found it super useful, so we've kept it around. And we've kept it around so much that, you need to be taught about it now, basically. So what's also very kind of common to see with percentages is percentage changes. So kind of saying with sale of 50% off, that means that kind of it's discounted at 50%. So that means, or the kind of the new price is 50% of the old price. So a percentage change, the way we can calculate it, there's actually a formula for this. So we have percentage change is equal to new value minus old value divided by old value times by 100. So this is the formula for percentage change. You'll see why this is in a second. You basically never have to write this formula out because it's kind of almost intuitive in this sense. So let me explain where it kind of comes from. So say, best thing to obviously do is kind of do this with an example. Say if I'm asked to calculate the percentage change, if you go from 5 to 7. So remember, this is change, right? What's the amount it's changed by? So this is changed by a value of absolute number of 2, right? 7 minus 2. So we can say the change is 7 minus 5, which is 2. But this tells us kind of the absolute change, right? But we might be interested in the relative change. Why we might be more interested in the relative change? For example, let's say if it was £5 to £7, right? This is the same as saying 500 pence to 700 pence. And we'd actually say this is a change of then 200p, right? Where this is £200, and this is the same. But kind of saying change of 200 seems so much more kind of extreme than saying change of 2. So what we're more interested in is thinking about how much has it changed in regards to its original value. So if you go from, for example, 5 to 10, that's a change of 5. But if you go from 1 to 6, that's also a change of 5. But going from 1 to 6 is such a kind of more, relatively, is a bigger increase than going from 5 to 10. Here you've doubled, here you've times by 6. So what we're interested in percentage changes basically show the relative change to the original value. And if you want to compare this to the original value, right, you have 2, so you divide by the original value, you have 2 over 5. Or maybe we should say not old value, say original. That's maybe a nicer way of saying it than old. Original. So we do 2 divided by 5 now. So if you want percentage change. So wait, I'll actually rewrite this. Let's preserve the initial thing we had. And if we want, percentage change, right? So if we compare this to the original value, we have 2 over 5. But this gives us whatever value we have, which gives us so kind of let's not call this a percentage change. Let's call this a relative change. It's 2 over 5, which is 0.4, and now we just have to convert this into a percentage. And the way we convert a decimal into percentage, or kind of any number into percentage, we just times by 100. So from going from 0.4 into a percentage, that comes out to 40%. So that's a 40% change, or 40% increase. We should specify the direction. It's increased from 5 to 7, so that's a 40% increase. What we might have is something like this, if it goes from 4 to 2. So again, if we use our formula, and kind of we can almost remember this intuitively though. We go 2 minus 4 all over original value of 4, and then times by 100, which we get as minus 0.5, which is kind of minus 50%. Or perhaps a better way to say it is 50% decrease. That's kind of the percentage change. Percentage change, you have to specify the direction. Has it gone down or has it gone up? I've lost so many marks for forgetting to specify this direction, even when you have, say, you have here, you can just rate it 40%, and you just think, oh, obviously that's an increase, right? Because I don't have a minus sign as I would here. But it's really important to specify this. Kind of minus 50%, say that this is a 50% decrease, and when you have 40% kind of as an increase, specify as an increase. Okay. So compare two quantities using percentages. So this is saying kind of if you have say value A, so you have 2 and you have say 7. If you want to compare them, you can say this is, say 2 is the amount of money Joe earns, and 7 is the amount of pounds say Bob earns, right? If you want to think about Joe's salary to Bob's salary, you can say Joe earns 2/7 of what Bob does. But basically you can convert this into fractions, so 2 over 7 times by 100, which comes out to 2 divided by 7 times by 100 is 28.6 to 1 dp percent. So Bob's salary is 28.6%. Joe's salary is 28.6% of Bob. So when you use percentages to compare quantities, it's the same thing as when you use fractions to compare quantities. Except in fact you just convert this into a percentage. And we've talked about how to do this. Just multiply by 100. Okay, working with percentages greater than 100. So that if we have, say, if something increases, right? If we have percentage change, or if we have a positive percentage change, right? So if a value increases by 10%, so say if we go from 10 to 11, this is a percentage change of 10%, right? Or what we can say is that the new value is 110% of the old value. That's another way we can say this. And the way we, you just do, we found the percentage change, and then we can add that to 100. So it's 110% of the old value. So when kind of when percentages are above 100, that indicates a percentage increase. So if it's gone from 100 to 110, so 110% of the kind of old value means it's increased by 10%. If we saw a number say like 400%, that means it's increased. So if it's say 400% of old value, we're saying it's increased. Percentage increase is 300%, right? Because 400 minus 100 is 300. So there's a 300% percentage change. So that means it's whatever you had. So if we went from 10 to 10, right? So if you increase that by 300%, that's to add another 30. So add it kind of itself 3 times over, and if you add 10 plus 30, that's 40. So 400% increase would mean to go from 10 to 40. And I guess a quicker way of calculating, say, 400% of old, saying 400% of new value is 400% of old value, is saying kind of, the new value is 4 times the old value, because which we just divide this by 100. So we can just do 110 times 4, for example. Solve problems involving percentage change, I'll do that in a second. Okay. And simple interest, I'll do that right then. I don't have a question explicitly for this, but I'll talk through that. Okay, so question 1, write down the decimal multiplier equivalent of the following: 25% decrease and 12% increase. Okay, 25% decrease, if that's a percentage change, right? So we start off by 100%. We always start off by 100% because 100% represents the whole. That's the original amount. That's kind of saying, 100% just, it turns out, 100 divided by 100 is 1, so 100% is just 1. It's like, it's the unit. And if we have a 25% decrease, right, we've gone from 100% down to 100 minus 25, which is 75%. So we've gone from 100% to 75%. So we only have 75% of the original. So if we want to convert, and now all we have to do is convert 75% into a decimal. So we go 75, and then divide it by 100. 75 divided by 100 is 0.75. And that's a multiple equivalent. If we have a 12% increase, again, everything with percentage changes is relative to 100. We start off with 100 because that's kind of our original amount. We're saying, when we say multiplier equivalent of an increase or a decrease, we're saying what is the new value as a proportion of the old value, but kind of as a decimal multiplier. So for example, if we were considering a 25% decrease, right? If we had the number 10, and we're asking what kind of multiplier will end up with a 25% decrease. So if a 25% decrease from 10 is you go down to 7.5, right? Because the way you might want to think about this is saying if we have 10, right, and then what's 10? Say if we have 25% decrease, right? What's 25% of 10? Well, 25% of 10 is what we do is 25%. We do 25 divided by 100 times by 10, which is 2.5. This is a decrease, so we go 10 minus 2.5. We get 7.5. This is the new value. Now we're asking so this is the new value, right? So 7.5 over 10, which is 0.75. So that's, if we multiply this number, this decimal, times by the new value, we should get to the old value, we should get to the new value. That's what kind of this decimal multiplier means. If we have a 12% increase now, 12% increase. Okay, so we start off again, remember, with 100%. We've increased it by 12%, so we get to 112%. And we just convert this into a decimal. So 112 divided by 100 is 1.12. And there we go. That's it. A company sells 1,490 pounds worth of clothes in a week. The following week they sell 20,000, I'm not reading that number out, worth of clothes. Calculate the percentage change in your sales. Remember, this is the formula we talked about. Percentage change. So new value 2911.80 minus old value 1149 divided by old value. Don't forget that times by 100, because if we don't times by 100, we're left with the multiplier equivalent. The decimal equivalent, right? What we were calculating here. But here we're also the percentage change. So we're not left with that was the wrong thing to say. We're not left with the decimal equivalent, but if we don't multiply by 100, we're left in the change in terms of decimals, basically, or in terms of fractions. We do this on the calculator because it seems fairly complex. Minus 1149. You come up to 82%. Don't forget the percentage sign. And that's it. Percentage change equals that. This is just a quick formula that you have to apply. A question like this. So Emily buys a new car that costs that. A year later, the car is worth this. Calculate the depreciation rate. So this is what the financial context kind of stuff meant. Depreciation rate is just saying kind of the percentage change, or perhaps better put the loss of value in a given year, or kind of thinking basically the percentage change in value for 1 year, or not necessarily even a year, but or a specified period of time. So you just all it's asking us to do is calculate the percentage change. That's what depreciation rate is. So we just calculate the percentage change. We go formula again, new value minus old value divided by old value times by 100. Get the calculator out. 20910 minus 25500 and 25500 times by 100 minus 18%. So therefore the percentage change is 18% decrease. Depreciation will always kind of, depreciation is negative, and the opposite of that is appreciation. So kind of if you're expecting a value to go up, for example, you say it's appreciating. So for example, the value of your house might appreciate because kind of you buy it for a certain amount of money, and so later you can sell it for a higher amount of money. So the value is appreciating. Whereas for example with a car, as you drive it around, it becomes older, it gets used, people don't really want to buy it, it's an older model. So the value of it will decrease over time, and that's called the depreciation rate. So depreciation, since you expect it to be negative, you just say 18% depreciation rate. Another question. Oscar buys a new question note that costs 23,000. The annual depreciation rate is 20%. How much is the car worth a year later? So this is saying for every year the value will increase by 20%. That's what the annual depreciation rate means. Remember, depreciation rate means the decrease in value for a given time, and they've told us the given time here is annual. So after a year, it's worth 20% less. So 20% decrease is the same as saying kind of 80% of the original. So, or perhaps, yeah, we can do 20% of 23,000 is equal to 0.2, or so 20 divided by 100, so 0.2 times by 23,000, which is equal to 4,600. So that's that value by which it's depreciated. So the new value is equal to 23,000 minus 4,600, which is equal to 18,400 pounds. And what this is, you can kind of tell almost, is just a rearrangement of the formula that we had. Percentage change is equal to new value minus old divided by old times by 100. So the percentage change we know is at negative 20. So negative 20 is equal to new minus old over old times by 100. So if we just rearrange, we know old is 23, right? Minus 20 divided by 100 times by 23 is equal to n minus 23,000. And that's basically what we've done, because the left hand side equals minus 4,600 equal to n minus, right? And then we add 23,000 to both sides, so n is equal to 23,000 minus 4,600. So what I've done here is basically a kind of just a rearrangement of this formula, but kind of think of it a bit more intuitively rather in terms of the formula. Another way of saying is that if kind of the value of the car is depreciated by 20%, right, it means that the new value is 80% of the original value. So if we start off by 100%, and now we've gone down by 20%, so we're at 80% of the original value. And so 80% of the original value is just 0.8 times by 23,000, which is kind of the same thing that we had before, 0.8 times by 23,000, which, yeah, 18,400. Okay, another question. This is, I don't know why I decided to stay here. I'll copy it again. Okay, a laptop goes on sale for 30% off. The sale price is £322. Calculate the original price. Okay, so if the sale price is 30% off, right, it means that the new price is 0.7% of the original price, right? Is equal to 100 minus 30 over 100 of original price, which is 0.7 of original, and 327 is 0.7 times original. So if we divide both sides by 0.7, we have original is equal to £460. Perhaps it might be actually worthwhile to go through this a bit slower. So if the laptop is going on kind of sale for 30% off, right? Or actually, let's kind of think of this in reverse. You can say let the original price be X. X, if we discount this by 30%, so X, and then we do percentage change of 30%, so minus 0.3X, because 30% decrease is just 0.3X decrease by that, is equal to new price, which is 322. So 0.7X is equal to 322, and we divide both sides by 0.7, so we get 460. And basically, when if we want to go from, if say we know, for example, that of the original, so say something is 70% of original price of price. If we want to calculate what 70% of something is, we just do 70 divided by 100 times by our original value, right? But if we know something is kind of 70% of something of kind of an original, we had to divide by this instead of multiplying it, because what we've done is 0.7 times original to get the new value. So but we want to go in reverse now. We want to find the new value we want to find the original value now that we have the new value, so we divide by 0.7. But we have already, we've already gone this way. We want to go back from this to that. We've gone from left to right already. We want to go from right to left to get the original. So we divide by 0.7 basically. I know that was a bit of a jam-packed video. There was quite a lot in there, and percentage changes, if you haven't seen them before, can kind of throw you off. So it's really important, there's quite a few different things that happen here, so it's really important to practice all of these different kind of types of questions. They come up fairly often, but once you can do them a fair few times, they'll kind of be easy marks for you to pick up, because you'll know how to do them. And kind of the lucky thing about percentages is that there's only so many types of questions that can be asked. And I did promise I'd talk about kind of interest payments, for example. So just to give you some real-world financial context, when kind of you borrow from a bank, they charge you interest, and that's basically them charging you for borrowing from them. They're saying, we're not just going to let you borrow for free, we'll actually charge you amount of money. So if you, for example, borrow £100, they might say you have to pay 1% interest, which is saying, for 1% interest per year, for example. So that means every year you have to pay, on top of the loan you have a kind of, the loan value will increase by 1% basically. So what you'll say is kind of after a year, the amount you'll have to pay back is 100 times by, original amount you had. So sorry, you have to pay obviously the original amount you have and the interest. And the interest is 1%, right? Which is 1 divided by 100 times by 100, since in this case you borrowed 100, which is £1. So after a year you have to pay 100 plus £1 back. After 2 years, for example, you have to pay the 101 you have originally, right? But now you also have to pay the interest again on the £101, which is say 1 over 100 times by 101, which is kind of a bit over 1, right? Which is what is that? Sorry, it was 1.01. So now you have to pay back at the end of year 2, you have to pay back 102.1, for example. So that's what interest is. So in short, kind of interest will be given to you as a number, or as a percentage. If you want to calculate how much has to be paid back after, for example, a year, you do your original value times by 100, and then whatever value you have, so 1.01 in this case. But if you had, say, 10% interest, that means after 1 year, you have a percentage change, if you think about it, of 10%. 10% of the value you'll have to add on. So you have 110%, which is 1.1, so for example. Whereas this, 1% year is 101%, which is 1.01. Hopefully that all made sense, and I'll see you guys in the next video.